Let's graph exponential functions using transformations. So the parent function of an exponential, f of x equals b to the x, where b is any number, right, and x is our exponent. Now, if this is the case, we have a horizontal asymptote of y equals 0. So if this is my coordinate plane, then horizontal x asymptote, meaning our graph is never going to touch the x-axis, so we have no x-intercept. We do have a y-intercept at 0, 1. That is where the graph will cross the y-axis. We'll find the rest of the points first. We're going to plug in 1 for x and solve for y, and then find other points as needed. The domain is all reals, negative infinity to positive infinity. And because we have this y equals 0 horizontal asymptote, our range starts at 0 and goes to infinity. So the possible y values are 0 to infinity. Okay, horizontal shifts. So if I have f of x equals b to the x minus h, notice this is connected to the x variable. When that is the case, then we have a horizontal shift. So if I would have f of x equals b to the x minus 2, or f of x equals b to the x plus 2, well, if it's x minus 2, we are going to go right 2 units. And if it's x plus 2, I'm going to go left 2 units. Okay, so horizontal shift, it's always kind of like the opposite of what it looks like. So x minus 2, we're going to move to the right. X plus 2, we're going to move to the left. I oftentimes think when I talk out loud, the more I say these things out loud, then the easier it is for me to remember. Vertical shift. A vertical shift can be seen in the function by looking outside of the variable. So I'm going to have x as my exponent. If a number is with that x, that's a horizontal shift. And if it's outside, like this k, then we have a vertical shift. So if I would have f of x equals b to the x plus 2, and f of the x equals b to the x minus 2, plus 2 on the outside means we're going to go up 2 units, and minus 2 on the outside means we're going to go down 2 units. These transformations are the same with logarithms, absolute value, quadratics. They're the same rules across all functions. So we're going to graph f of x equals 2 to the x minus 3 plus 4 and the parent function. Now, I want to do the parent function first, because if you can graph the parent function, which is usually easier, then you can just use your movements to graph the other function. Okay, so the parent function is just the base to the x. So the parent function is just 2 to the x. Okay, so let's think this through. If I just want to do, let's just do 3 points, -1, 0, and 1. Let's just start there. If x is -1, that gives me 2 to the negative first power, which is 1/2. So my ordered pair is -1, 1/2. If I plug in a 0, 2 to the 0 is 1. So my ordered pair is 0, 1. My y-intercept, we've already talked about that a little bit. And then if I plug in a 1, 2 to the first equals 2, so my ordered pair is 1, 2. Now, if you want to do another one for 2, 2 squared is 4, so the ordered pair would be 2, 4, and that's fine. So -1, 1/2, 0, 1, 1, 2, and 2, 4. Remembering that this is our horizontal asymptote here. So we're not going to cross or touch the x-axis, right? Just keep that in mind. Okay, so now I'm ready to graph my transformation. I'm going to make this line a little fatter. So first we have x minus 3. So -3 minus 3 is part of the exponent. So that is a horizontal shift. So that's going to go right 3. And then this plus 4 out here means I'm going to go up 4. So we can see that I graphed 4 points, excuse me. I graphed 4 points. If I move each one of those points, right 3, up 4, I then will have my new graph. Now also, because we're moving up 4, my entire horizontal asymptote, 1, 2, 3, 4, is going to move up 4. Just keep that in mind. If you have a different colored pen, it might be a good time to use that. Okay, so write 3 up 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, wait, I counted wrong. Oh, goodness, I can't even count anymore. Maybe I should go back to bed. Okay, from here, 1, 2, 3, 1, 2, 3, 4. From here, 1, 2, 3, 1, 2, 3, 4. From here, 1, 2, 3, 1, 2, 3, 4. Okay, let me get rid of all of these extra dots. Okay. Get my asymptote back here. And I didn't do the other one here. That's this one. 1, 2, 3, and then 1, 2, 3, 4. Okay, so now I have my new graph. So you notice they're going to look the same, right? They've got the same curvature, but the difference is your asymptote shifts up, and every point shifts in certain directions. In this case, we're shifting right and up each point. So sometimes I think it's easy if you have, or easier, excuse me, nothing is easy, easier if you have different colors or if you have a pencil and a pen to show, okay, I can do my parent function in pencil and then maybe I graph my transformation in a red pen so that you can see the difference. If you do everything in the same color, sometimes it can be a little bit more difficult. Or get a green pen and use that for just your asymptotes or something like that. Colored pencils, crayons, all of these things are helpful to kind of just note the differences. And the more you can talk out loud and stay consistent with how you're doing these things, the easier it will get over time. So notice with this that our domain is still negative infinity to infinity, and our range now starts at 4 and goes to infinity because we're not coming anywhere below x equals 4. And the new horizontal asymptote is y equals 4. All right, there it is.